Welcome to VW 9.6. Today we're going to be talking about solving log equations. So the only thing you have to really remember here is you have log form right here, and then you have your exponential form. So if you have this here, you're pretty much good to go. So let's try our first example. Notice how you're in log form here. So the goal for this is you want to get rid of the log, and for now the only way you can really do that is to convert to exponential form. So 3 to the second equals 4x minus 7. So 9 is equal to 4x minus 7. 4x would equal 16, and x is equal to 4. And that's good, that's it. And if you wanted to check if it worked, it's pretty easy. Plug in 4 right here. That's 16 minus 7, which is 9, and log base 3 of 9 is clearly 2. Next example, we have x squared equals 64 when you change to exponential. And this is a bit unique because as we know when we root it, we get absolute value of x is equal to 8, which means x is going to be plus or minus 8. However, this is a fine detail of a log. The base has to be positive. We'll never have a 0 or a negative base because for a log it wouldn't really make sense. Like you can't have log base negative 2 of something because it wouldn't be clear what to do. So because of that, we just cross out the negative answer, and x is only 8. Now we go to the next part. You're going to see e's here, and it's really the exact same thing. So we'll put a separator. If you see an e, I'm going to give you this generic form here. Let's say if e to the x equals a, this is still exponential form. You just have an e, which means there is an equivalent log form. But remember, for e, we use a natural log. So this is going to be natural log of a is equal to x. And in case you forgot, remember natural log, that's the same thing as log base e. So that's the exact same thing. Now, if you also notice that these questions are slightly different because look where the x is located. It's actually in the exponent for both of these, versus here, the x's was like in the log. So to do this, it's actually quite simple. You just put it into log form, and you're going to see that's kind of cool because when we do that, we're going to get natural log, that's going to be 5 equals 2x. So notice how by putting it in natural log form, we actually free this x in the exponent, so now it's by itself on the other side of the equation. Natural log 5 is a number, so now I just divide by 2, and x is going to be natural log 5 over 2. Now let's go to our next one. Notice how we're in the exact same situation, except you have a 5 here. So you want to remember that you don't want to put this into log form if you have a number there. So I want all of you to highlight that and note, get rid of this first. If you try to put a log in, it's going to make it really complicated. So get rid of that number. So it's pretty easy, just divide by 5. And now we're in our pure exponential form. Let's change it to a log. So natural log 3 over 5 equals negative 2x plus 3. We're going to subtract 3. And make sure you put parentheses here to make it clear that you're only going to natural log this number. That's minus 3 equals negative 2x. And finally, here's our answer. The natural log of 3 over 5 minus 3, all divided by negative 2. And that is our answer. We can leave it like that. Now to our final question. This is going to be reviewing a couple of things to make sure we can graph a log. This says graph the following function, then find the inverse, sketch the inverse. So let's first start by graphing this. So I'm going to rewrite it. Hopefully you've been trained now. Whenever you see a 1 minus x, you want to factor that. So I have this now. And now I can see the transformations. That's y times 3 reflect over x and y axis. And then write 1 up 2. And if it helps, you can state the parent graph would be log base 4x. Now, whenever you graph a log, remember the parent points. The parent points are going to be 1, 0, and base 1. That's always going to help you figure out how to graph a log. So I'm going to put my parent graph here, 1, 0, and that'd be 4, 1. And I might erase that later. I'm just using that as a guide for now. Let's apply the transformation. So y times 3, reflect over x and y. So this point doesn't move. Reflect over x, nothing happens. Over y is right here. And then right 1 up 2. So right 1 up 2. So there's our new point. 0, 2. And you can always confirm that point just by plugging in 0, because I can say if I plug in 0 here, that would definitely work. And then this point, this is 4, 1. Let's do y times 3. So that's 4, 3. We're going to reflect it over x and y. So that would be 4, negative 3, negative 4, negative 3. And then move it right 1 up 2. So 1, 1, 2. So negative 3, negative 1. And again, if you ever want to check on a test, just plug it in, and you can see that that does in fact work, because negative 3 would make this 4, and then you get negative 3 plus 2, so this definitely works. And to make it easier, I'm going to put my asymptote in. The asymptote is going to be right at 1. And you might wonder, like, how did I do that so quickly? All I'm doing is I'm looking at what makes this thing 0, and that's going to be our vertical asymptote. So that's kind of a quick trick to figure out where that would be. And then from there, I can definitely see my graph, something like this. So there's f. Now it says, then find the inverse and sketch it. So I like to just graph the inverse first because it's pretty straightforward. Flip the point, so I have 2, 0, negative 1, negative 3. And then I should have a horizontal asymptote at 1. And then I'm just going to sketch it. And again, some people like to find the inverse first, but I like graphing it because I think it's pretty easy to graph. Then it's already done. So now let's find the inverse. So I'm going to switch x and y. X is going to equal negative 3 log base 4, 1 minus y plus 2. I'm going to subtract 2, divide by negative 3. That's going to be log base 4, 1 minus y. Let's change the exponential form. So 4 to the x minus 2 over negative 3 goes 1 minus y. And then let's just rearrange this a little bit. So I'll move the y and subtract the 4. And then look at that. There's our inverse. F inverse is going to be negative 4 to the power of x minus 2 over negative 3 plus 1. Now for the final touches, we need domain and range. So let's make our little chart. F inverse, domain, range. So F is the black line. I can see my domain is negative infinity to 1. And then the range is all real numbers. And I'll do the shortcut. Let's just flip these around so I know the range will be the domain here. And then the domain here should be the range. And we are done.